So section 2.3, properties of functions. So what are we going to do here? Well, number one, we're going to determine whether a function is even or odd or maybe neither. Identify them from equations and identify them from a graph. And then we're going to get more properties or more information out of a graph of a function. That is, to determine where a function increases, decreases, or remains constant, flat. You'll see how we're going to get to that. And then we're going to use the graph to obtain or to locate local maxima and local minima, as well as absolute maximums and absolute minimum values. Well, actually those go very close to what we do with increasing, decreasing intervals of a function. But number one, okay, let's talk about even and odd functions. Number one, okay. This might be a little weird at first because, well, how are functions even? How are functions odd? I mean, that's something more like properties of numbers, like a number is even, like 2, 4, 6, 8, numbers that are divisible by 2. As opposed to odd numbers that are 1, 3, 5, 7, numbers of the form even number plus 1, so 4 plus 1 equals 5. 4 plus 6 plus 5 equals 7. That's how we get the odd number. But how is this related to functions in terms of their parity? Well, so a function f of x is considered even if for every value of x in its domain, the number negative x, that is, that if we change the sign to the input, that function value is exactly the same, right? So that's key right here. Now, graphically, how do we see this graphic representation? Well, an even function is a function that is symmetric about the y-axis. In other words, you can think of the y-axis as a mirror, and you will see the same graph on both sides of that. And if you can see the same graph or the same picture on both sides of that mirror, then the graph that we have is going to be one that is representing an even function. As opposed to a function that is odd. How do we know that a function is odd? If for every number x in its domain, the number negative x is also in the domain, but in this case, that indeed outputs the negative y value or the negative function value. Well, these conditions right here might look a little weird, especially because of the symbolic representation, but actually we're going to see this in action with plenty of examples. And now, graphically, an odd function is symmetric about the origin. So in this case, the origin, the point 0, 0, is going to be the mirror for that function. And if we are able to see the same graph in a weird way, well, that's going to be different. You'll see. Well, then the function that is represented, it's an odd function. Well, let's get some practice with graphs right here. All right. So number one, to determine whether a function is, let's determine whether a function, or rather, that these graphs represent an even function, an odd function, or maybe neither one of them. All right. So number one, what did you notice about the first graph? What did you notice about it? And in this case, since we were looking at their graphs, in this case, we are thinking of the symmetry. Is there some symmetry at all for the first graph? How can we describe that symmetry? Mirrored, but yes, with respect what? To the y-axis. So in this case, we can see that the y-axis is like the mirror, isn't it? It's a mirror, and well, this point is a reflection of that point, or vice versa. This point right here is a reflection of that point, or vice versa. So in this case, we're getting, if this is x, all right, this point, x equals to, and that's f of x. And if we change the sign of x to negative x, did you see how we still get the function value, the positive f of x? So that's another way to determine that this function indeed will be even. Even, and that's because symmetric about the y-axis and also for all x's in here, if, or rather f of negative x, it's still back to the positive value of f of x. Okay, let's have a look at the second graph. And from here determine whether this graph is even, odd, or neither. That is, maybe the graph is symmetric about the y-axis, maybe it's symmetric about the origin, or there's no symmetry at all. What do you think of this one? Just no symmetry. Okay. Let's think of this. Okay, let's determine whether, in this case, the y-axis serves as a mirror. Well, the point right here should be reflected over here, right? But it's not. It's not there. So, at least not symmetric about the y-axis, so it's not even. Let's determine whether it could potentially be odd. Well, so in this case, if I choose this point right here, that point, let me call it x, and that's going to give us some point, some y value, some function value f of x, which we usually call it y. All right? Now, if I go in this case towards the negative side, that's negative x, technically I should have this point reflected about the origin. In this case, right here, I should be having this point reflected about the origin. That is where negative x becomes negative f of x. But it's not. Actually, that's a point in the middle of nowhere. Instead, I have this point over here. So from here we can see that there is no symmetry at all. So in this case, neither even nor odd. Right? What about the third graph? Do you see any symmetry at all? Yes. A point, not about the x-axis. What is that again? About the origin. Okay, let's see about it. Okay, so let's take any random point. All right? Any random point, like this is x. Okay, let me do this one. So this is x. This point, the y value will be the f of x, the function value f of x. All right? So in this case, well, if I change the sign of this value of x, that's going to send this same value, say 3. For instance, say it's 3. I'm going to send it to negative 3. Change the sign of x. That's negative x. But now check this out. Did you see how this function value, it's no longer positive, it's negative this time. So that is negative f of x. And in fact, well, did you see how the origin in this case, this point, is the very middle, or the very middle point between these 2 points, right? So this should work as a mirror in this case, right? This is the very middle, and it's also a mirror. So that means odd. Symmetric, that's because it's symmetric about the origin. Also, for all x, f of negative x, if we change the sign of f of x, that outputs the negative value of the function, which is the case right here. Well, so that's like the introductory idea to determine whether a function could be even or odd. And that's by checking the symmetry of the function, by looking at its graph rather. All right, now how do we go about the algebraic process? And this is very key to determine whether a function is even or odd. Okay, determine whether each of the following functions is even, odd, or neither. All right, so this is what we're going to do. Let me write down in a way the steps on the side. Replace x with negative x, right? If the result is still f of x, then f of x is even. Number two, if the result is the opposite in sign of f of x, that is negative f of x, then f of x is odd, else is neither. And we're gonna look at one case of it for this couple of examples. It's actually 3 examples. All right. So let's see. H of x equals to the quantity x over the quantity x squared minus 1. Let's determine whether this function is even, odd, or maybe neither. All right. So number one, what we do is replace h with the quantity negative x. All right, that is, I'm going to replace this with, not this one, that one, negative x. Replace x with negative x, quantity squared. All right, and then what do we get from here? Well, let's keep simplifying this. Then in the numerator, negative x is simply negative x. There's really nothing else to do. That's negative x. Now, divide that by negative x. Quantity squared, well, what do we get when we square negative x? What is that again? Positive. Positive x squared. Recall negative being squared or negative raised to an even power remains positive, right? And then minus 1. Now, here is the thing. So now when we're done with the algebraic process, by the way, and here is where we need to compare this expression. We compare this expression with the original expression. How are they related, or how are they different from one another? One is negative and one is positive. Okay, let me do the following. Let me factor out the negative. Let me write it in the front. Negative x over x squared minus 1. Now, do we agree that this whole thing right here is the same whole thing right there? However, with an opposite, with a negative in the front. So in this case, h of negative x equals to negative h of x. Now, what did we get? We got the opposite in sign of the original function. What does that mean? Do we have an even function? Do we have an odd function? Or do we have neither in this case? What do we have? Odd function. All right? So h of x is odd. All right? Let's do the next one. Okay, let me bring this data here, down here. Okay, we have the function f of x equals to 2x squared minus a quantity, 2x to the fourth rather, minus a quantity x squared. All right, so let's see. So what we're going to do, first of all, replace x with negative x, that is 2 times quantity to the fourth minus quantity squared. And then from here, what is it? Negative x, change with negative x, change with negative x, change with negative x. Now, careful with the end result in here. So let's keep writing that f of negative x, which is the operation we're doing on the function f of negative x. Remember when we evaluated functions the first time, we did a bunch of evaluations for functions like f of 1, f of 7, and then we did f of negative x, and then I mentioned that we needed this to connect with the evenness or the oddness of a function. So now here is where we're applying that. So what do we get when we raise negative x to the fourth power? Positive x, so that's 2x to the fourth, to the f to the fourth power, minus, careful because this minus here is not affected by the square here, and negative x to the second, that means positive x to the second, but with the negative in front, that means that's still negative. Now, that's the final answer right here of changing x with negative x. Now compare these results with what we have in the original function. How are they related or how are they different? They're the same. So in this case, what do we have? F of negative x equals to, what's that? The original function f of x, right? So what would you say about this? Even or odd? Even, right? Right? Let's have a look at letter C. Having a look at letter C, what do we get? Well, so that's, okay. F of negative x. Let's do negative x plus the absolute value of negative x. All right, need to be careful here because, well, so negative x for the first term is just negative x, right? That's just negative x. That means, okay, so f of negative x equals to negative x plus, okay, you need to be careful when simplifying this absolute value. Okay, so here we need to talk about the properties of absolute values. So the absolute value of a product between two quantities in here, that's the same as taking the absolute value of A and multiply with the absolute value of B. All right? So, and well, how is that going to play out over here? Because you see this negative in front of the x, that's technically a negative 1 multiplying. That's a coefficient. That's what I'm trying to say here. So, okay. That's absolute value of negative 1 times x. And then we have the product rule for, or the product property for absolute values. So that's going to give us f of negative x equals to negative x plus the absolute value of negative 1 times the absolute value of x. And what's the absolute value of negative 1? 1. All right, so that's f of negative x equals to negative x plus 1. I'm not going to write, well, I'm going to write that 1 just so you can see where it's coming from, times the absolute value of f of x. Well, no need to write that 1, f of negative x equals to negative x plus the absolute value of x. Now, compare this result here with that result there. How are they related? Are they the same result? Are they opposite in sign? I mean, is the whole thing opposite in sign? No. Not the whole thing, right? It's only the first term, the one that it's opposite in sign. All right? So even if you try to factor a negative, check this out. Okay, let's think of that. Let's do it. Factor out the negative x minus, right? absolute value of x. So if we think of this, oh, maybe f of negative x is negative the original function, to conclude that the function is odd in this case. However, well, we have positive x as in the original, however, not the second one is also positive. So in this case, neither. Alright, how about we have a look at the graphs of this function so we can verify that parity, the evenness and oddness of this given functions. Okay, let's start with the first one, letter A, x over x squared minus 1. So let me assume standard, let me change the function. Let me just do delete, 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 and that's x over x squared. Oh, okay, delete, and then in this case I'm gonna do second inserts square. All right, and let's graph it. And as we can see in this case, that's an odd function. If we consider this point, for instance, that's whatever x is in this case, that's the y value. If I go towards the negative side, it's going to give me the same y value but opposite. And in fact, the origin right here serves like a mirror, and see how these points are a mirror images, but in this case not about the y-axis but rather about the origin instead, right? Now let's have a look at the other graph, the other function. Let me go back and edit the y. Need to clear the whole thing. What is that? 2x to the 4 minus x squared. 2x to the 4th power minus x squared. And graph. We can easily see that this graph is symmetric about the y-axis, right? Which checks with what we did algebraically, we got that it is indeed an even function, right? And let's do the last one, that is y equals, what is it? X plus the absolute value of x. Okay, let me clear the whole thing. X plus math. Let me go to num to get the absolute value. Okay, so that's good. The good thing is this gets recorded, so when you get back to try and reach out these functions, you see them how to get the absolute value. Click enter. That's going to give us the absolute value bars, and let me just do the x right here. And let's have a look at the graph, and we can see this graph is not symmetric at all. All right, it's not symmetric. There's no. It would have been great to have another diagonal here, like the V-shaped kind of graph, absolute value by itself, right? But that x term is making this horizontal line, and well, here again we can verify that this graph represents that of neither even nor odd function. All right. Let's see if we have anything else. And well,